All right, everybody. So this is your instructor, Jeff, and I'm back because I wanted to show you some more things about the mean, median, and mode. But I think for what I need to show you now, it's best for me to show you some things in the e-text and give you a little bit of my commentary about it. Okay, so right now you can see that I'm in my math lab, and here's the typical menu, and I can see the assignments that we have up. And so I go to eText, all right, and it says view the eText. And whenever that gets here, if that ever gets here, then I'll show you. Okay, well, this is awkward. Wait a second. Okay, we'll get there. All right, here we go. So here's the e-text, and you'll find that when you do the homework assignments, textbook is one of the help features, and that will bring you to the part of the textbook that is relevant to that part of the problem. But for now, I have a particular part of the book that I want to show you. So I'm going to go to measures of central tendency. Okay, so here we are, and we've learned about what the mean, median, and mode are and how to calculate them. And in the video I just made, I had told you a little bit about outliers, okay? And this time I want to show you in terms of graphs what outliers look like and how they can affect the mean, median, and mode, all right? Anyway, so there's this example right here where you have the ages of students in a class, okay? And the mean, median, and mode are calculated by way of example in the book. And then like here is the frequency distribution of that data. Okay, now in much earlier videos, I showed you how to take the raw data and make the frequency distribution, which is the graph, okay? But I want you to see how if you could see all the data on the graph, the frequency distribution itself, and I want you to notice on top of that where the mean, median, and mode are, okay? So first, let's see, here's all the data. So I read this, there's like 6 students that are 20 years old in the class and so on. And then look out here, there's one student that's 65 years old in the class. And there's this huge gap in between them, all right? The oldest student up to that looks like it's 25 years old, and there's 2 of those. But, you know, if you calculate the mean, median, and mode, look at how they're scattered through the data as a whole. So in my last video, I said, well, when we give the mean, median, or mode for a data set, we're trying to give a number that describes a typical entry, okay? And which one of these do you think would describe a typical entry? You know, the data is like kind of clustered here in the middle, I would say. You know, the mode of 20, there are 6 people that are 20 years old. That's the most common entry. But I wouldn't say like with several students that are 21, 22, 23, 24, 25 years old, I wouldn't say with all that that the mode represents a typical entry, okay? And also with the mean, I wouldn't say that represents a typical entry either, because look, it's like skewed over here to the right. So the mean, let's see, what's that, 23.8 years old over here on the far end of the data set. You know, I'd say the typical entry is more in the middle, all right? Right around here, like 21 to 23 or something like that. So I wouldn't say the mode is typical, representing a typical data entry. And I wouldn't say the mean represents a typical data entry. I think it'd be the median. See how the median turned out right there in the middle? So I think this time it gives us a number that best describes a typical entry in the data set. Okay. All right. So, you know, it may be helpful to see the data set and a frequency distribution in order to decide which one of these, mean, median, or mode, represents a typical entry in the data set. All right. Now, as far as outliers go, 65 is definitely an outlier. It's way outside of the other data entries. So, you know, sometimes we might do this. Outliers can be mistakes. Maybe the data was misreported or something. Maybe somebody meant to write down 25 and they wrote down 65 on accident, you know. That's at least sometimes the case. Mistakes do happen, and if there's a data entry that seems just wildly different than all the others, it could be a mistake. It doesn't mean it is, but it's possible. And so, you know, sometimes we might remove outliers if we thought that that was the case. In the book here, it says, well, how about remove the entry 65 and then rework the example, calculate the mean, median, and mode, just to see how it would change it, okay? Remember, the mean is very sensitive to outliers in general. So, you know, as it says this, to rework it is an exercise to show you how that number 65 is really skewing the mean pretty far to the right as I'm looking at it. Okay, so moral of this example, sometimes it helps to see the frequency distribution graph in order to tell which best represents the data set, mean, median, or mode. Okay, now one more thing, there is some vocabulary and related information about frequency distribution graphs and their shapes. Okay, so now the reason I'm doing the video this way, I don't normally, my goal is not to read the book to you. Normally I make slides for videos and put them together myself, but these graphs are really good and better than I can hand draw in any reasonable amount of time. So here are 4 common ways that frequency distributions can appear. Now remember, we covered frequency distributions in an earlier video. And then the very next video was the graphs. Okay, so these are the graphs. So this one's called symmetric. It's also called normal distribution sometimes, but here for now we'll call it a symmetric. This one is called uniform. Well, let's give a few takeaways. With a symmetric distribution, looks like most of the data entries are in the middle. Okay, most of the data entries look between 34 and 36. Okay, or sorry, I take it back. Most of the data entries look between 7 and 9. For this to be 7, there were, looks like 34 entries of 7. So most of the data entries look between 7 and 9. Not very many out at 15, not very many out at 1, you know, like that. So that's called symmetric. The reason it's called symmetric is you could split it right down the middle and both halves look the same. That's what symmetry is. Okay, our faces have symmetry. Right down the middle, the left and right half look roughly the same. Okay. This is called uniform distribution. And by calling it uniform, it means that every data entry was represented with the same frequency. So in this data set, the number 1 occurred 20 times, but so did the number 7, and so did the number 15, and so did all of them. That's what a uniform distribution is. If any one of these, like if the data entry 3 occurred more than 20 times or less than 20 times, well, then it wouldn't be uniform because they wouldn't all occur with the same frequency. Okay, so we got symmetric, we got uniform. Now, these two, skewed to the left, skewed to the right, are variations on the symmetric. Like, what if the symmetric was tilted over or scooted over a little bit? You know, what if there was just a little more over here than over here? Okay, so that's how we get skewed left, Okay, you know, imagine you took the middle, the peak in the middle, and moved it over here. That's called skewed left. Or imagine that you took what would be the middle of the symmetric distribution and moved it over here. That'd be skewed right. Okay, now those are the different shapes of frequency distributions. From here, though, I need you to see how the mean, median, and mode becomes scattered through the data set, okay? So if it's truly symmetric, the mean, median, and mode are all the same number right here in the middle, okay? If it's uniform, the mean and median occur right here, also in the middle. All right, because there's 7, there's 9, 8, okay, right in the middle. Why isn't the mode given in this one? What is the mode? The mode is the most frequent data entry. Well, they all occur at 20. What would you say? Every number is the mode? Okay, so there's not a mode on this one. And in skewed left, the mode is to the right of the median, and the mean is to the left of the median. And then in skewed right, we get the opposite. The mean is to the right of the median, and the mode is to the left. Okay, now so that's like one, we should know the names of the basic distribution shapes, and we should be able to identify them when we see them. And two, like basic information about means, medians, and modes is how they occur on those 4 distribution types. Okay, like I said, I don't normally use the book. I don't have any problem with the book, and I think it's great if you make reference to it when you do the assignments on MyMathLab. I think it's a pretty good book. I like a lot of the pictures. I think it's pretty easy to read. That's my opinion. But for this video, what I wanted to show you really just happened to be in the book. All right, hope it helps. So with any of the videos, if you have any additional follow-up questions or whatever, other suggestions for videos, anything, let me know because I'm happy to help out.